Conditional probability. This is all about the likelihood or probability of an event changing when we know more information. So for example, the Venn diagram shows the number of students doing art, biology, both or neither from a particular class. So A is those doing art, B is those doing biology, the 7 in the middle means they do both, and the 5 out here do neither subject. What is the probability that a randomly chosen student from this group does art? Well, how many students do we have altogether here? So if we add all of these up, we get 40. We can see that these 20 and these 7 do art, so that means that 27 out of 40 do art. What is the probability that a randomly chosen student from this group does biology? So, biology is 7 and 8, so that's 15 out of the 40. And of course we could cancel that down. 5 goes into both things. 2, 3 eighths. What is the probability that a randomly chosen student from the group does biology given that the student does art? Now this is where the conditional comes in. We know some more information. Therefore we are only choosing from these students because we know that the student does art. And that means the denominator becomes 27. How many of these do biology? 7 of them. So the probability is 7 out of 27. And note that isn't the same as 3 eighths. What's the probability that a randomly chosen student from the group does art, given that the student does not do biology? So if they're not doing biology, we know that these students are not involved. So now it can only be out of 25. How many of those students do art? We can see that's 20, and that one cancels down to 4/5. And note that this probability is not the same as this one. Of 200 people surveyed, 63 of the 97 males were for increased penalties for drug offences. A total of 62 people were against increased penalties. Complete the two-way table below. Well, we know there's 200 in total. We know there are 97 males, and 63 of those were for increased penalties. A total of 62 people were against increased penalties, so that must be 62 just there. So there must be 103 females, and let's just bring in the calculator. So 97 is the row total here. Take away the 63 we already have, so that's going to be 34 in here. And then 62 is the column total here. Take away 34. That gives us 28. So we need 28 in here. And 103 is this row total. If we do 103, take away our last answer, that gives us 75 in here. And then to get the column total there, we'll add 63 to that, 138. And just to check, 138 add 62 does give us 200. What is the probability that a randomly chosen person from the survey is for increased penalties? So this is completely unrestricted, and our probability will be out of 200. So those 4 increased penalties are 138. So that's 138 over 200. And we could cancel that down. I'm not going to worry about it. What is the probability that a randomly chosen female from the study is 4 increased penalties? Well, now we have the restriction that we know we're choosing a female. So therefore, it's going to be out of 103. How many of those were 4 increased penalties? Well, 75. So we can see the 75 females 4. Given that a person randomly chosen from those in the survey is against increased penalties, what is the probability they're male? So now our restriction is that they're people against increased penalties, and we can see there are 62 of those, so our probability is out of 62. Then for the males, there are 34 of those. Once again, we could cancel this down, but let's not worry about that. The box below contains 6 yellow balls and 4 green balls. If I pick a ball at random, what is the probability the ball is yellow? So 6 yellow and 4 green means 10 altogether. So it's going to be 6 out of 10. Let's not worry about the cancelling down. A yellow ball is removed from the box and not put back. What is the probability the second ball taken is yellow? So if we've taken a yellow one and not put it back, we're now in a situation where we have 5 yellow and 4 green. So the probability of this second one being yellow will be 5 out of 9. Draw a tree diagram for taking 2 balls from the box if the first is not put back before the second is taken. So the first branch represents the first ball, which could be yellow or green. Now we know that this is 6 out of 10, and this one would be 4 out of 10 because there's 4 green balls. Now for the second ball taken, it could still be yellow or green, whatever happened the first time, but we looked at this situation here. We've taken a yellow out, not put it back, so we now have 5 yellows out of 9. There's still 4 greens, but out of 9. If we got to here, we would have taken a green one out of the box, and this yellow one would still be there. So we'd have 6 yellows and 3 greens. So yellow would be 6 out of 9, and green would be 3 out of 9.